Students, welcome back to Chemical Kinetics. Here in this module, we will understand the effect of temperature on rate constant. It's the first part of the video. Now here, in one of the previous modules, you have studied Arrhenius equation. Arrhenius equation gives us the relation between temperature and rate constant. Now here, let's see how temperature affects the rate of reaction and the rate constant. Well, if you remember this slide from one of the previous modules, you will also remember that temperature happens to be one of the factors that affect rate of a chemical reaction. We had seen earlier the dependence of the rate of reaction on temperature, how the rate of reaction depends on temperature, and in that topic we had seen that increase in temperature increases the rate of the reaction. Now this mainly happens due to two reasons. First of all, when you increase the temperature, kinetic energy of the molecules, it increases, and more kinetic energy means that you have more violent collisions. The collisions which are happening between the molecules will be much more violent at higher temperature. Well, the second factor is that more number of collisions are successful at higher temperatures as compared to low temperature. So these are the two factors. Number one, you'll have more collisions, and number two, those collisions will be more violent because the kinetic energy is more. In fact, if you remember, we had also discussed this thing. The reaction rate almost doubles for every 10 degrees Celsius rise in temperature. This can be explained with the help of the formula of temperature coefficient. What is temperature coefficient? It's nothing but the ratio of rate constant at T plus 10 degrees Celsius to the rate constant at T degrees Celsius. For example, rate constant at 30 degrees Celsius divided by rate constant at 20 degrees Celsius, and this is nothing but the temperature coefficient, and more often than not, it happens to be almost 2. You can also get MCQs on this. Anyway, now we were talking about collision of the molecules, violent collisions, more number of collisions. All these things are technically a part of collision theory. Anyway, we will discuss collision theory later on. Right now, what you need to know is that the rate of a chemical reaction depends on two factors which depend on temperature. The first factor is collision frequency, and the second factor is effective collision. Let's take the first factor, the rate of a chemical reaction depending upon collision frequency. So here's the first factor, collision frequency, the frequency of collision of molecules. Now here's the thing, if you increase the temperature, the average kinetic energy of the molecules increases. And when the average kinetic energy of the molecules increases, you can say that it increases the collisions per unit time. So the number of collisions will go up, and because of this, the rate of the chemical reaction increases because the number of collisions that were taking place per unit time has increased. But what you need to understand is that this increases the rate only by 3%, which means when you increase the temperature, collision frequency increases. But this factor, collision frequency, affects the rate of reaction only by 3%, which means it's just a minor factor. In other words, I can say the increase in the rate of reaction is simply not due to the increase in collision frequency. The other factor is also important, and in fact, it is more important, effective collision. So let's take this factor, effective collision. What is an effective collision? Whenever the reactant molecules collide in such a way that it gives products of course, the collision is effective. Now here, what you need to understand is that the basic requirement of the collision theory is that the reacting species must collide, and that is when you get a product. Now, only a small fraction of collision is effective, and for effective collision, in order for a collision to give you product, you need to understand the energy of collision must be equal or more than threshold energy. What is this threshold energy? If you just pause this video for a minute and give it a thought. If the energy of collision is greater than the activation energy, then I can say the collision will be effective. Just keep that thought in mind, my dear students. Whenever the energy of collision is more or equal to the threshold energy, we say collision is effective. So if the energy of the reacting molecules is less, the collision will be ineffective. And if the energy of the reacting molecules is more, collisions will be effective. So we can say that the energy of collision determines the possibility of a reaction, and it is indeed the major factor contributing to it. That's all you need to understand for this particular module. We will understand the following thoughts to this particular concept in the next module. Till then, take care.